Hello friends, we are going to talk about quadratic equations in this session. So let's first talk about the definition of quadratic equation. We know that a polynomial of degree 2 is called a quadratic polynomial. When a quadratic polynomial is used in an equation, then it becomes a quadratic equation. The degree of this equation should remain the same, which is 2. So when we are saying a quadratic polynomial used in an equation, so what we are saying is, supposing the left hand side of the equation is the quadratic polynomial, the right hand side of the equation again cannot have a degree more than 2, or so it could be either a 0, a constant, maybe a linear polynomial in the same variable, or a quadratic polynomial again, but it cannot have a degree of more than 2. So if we equate a quadratic polynomial to any constant or a linear or quadratic polynomial, then also it will become a quadratic equation. But in case the second degree component on the left hand side cancels with the second degree of the component on the right hand side, then it will not be a quadratic equation. Now, so for example, we take a quadratic polynomial x square plus 2x plus 5. Now supposing we use it in an equation in such a way that we make a right hand side of this nature. Now we clearly see that this component will cancel with this component on the left hand side. So we are saying necessarily this equation will not remain a second degree, will not have a second degree component, so it will not remain a quadratic equation anymore. So if px is a quadratic polynomial, then px equal to 0 is definitely a quadratic equation. So when we're talking about this part, supposing we have a cubic polynomial of this type, and this is equated with another cubic polynomial of this type. Now this can actually become a quadratic equation because this cubic component on the right hand side cancels with the cubic component on the left hand side. So this will necessarily become a quadratic equation. Now the general or the standard form of a quadratic equation is ax square plus bx plus c equal to 0, where a, b, c are real numbers and a cannot be 0. B or c can be 0. Either b or c or both of them can be 0, but if a is 0, then it becomes a linear equation, then it does not remain a quadratic equation. Now let's understand how do we form a quadratic equation. In word problems, we can solve the problems by first forming a quadratic equation from a given statement and then solve it for all possible solutions. Let's take an example. Say we have the product of two consecutive integers is 342. The area of a rectangular garden is 483 square meter and its length is 2 meter more than the width. So let's convert the first one. Product of two consecutive numbers, that means if one number is taken as x, the other number becomes x plus 1. The product of these is 342. So we can say this becomes a quadratic equation of the type x square plus x minus 342 equal to 0. So this becomes a quadratic equation which can be solved. Similarly, now supposing we take the length of the rectangular garden as L. Now the length is 2 more than its width. So we can say width becomes L minus 2, and the product of these two, which is the area of the rectangular garden, is given out to be 483 square meter. So this becomes a quadratic equation, L square minus 2L minus 483 equal to 0. So this is how we form a quadratic equation in case of word problems. Some other type of equations can also be converted to quadratic equation. Say for example, we have an equation of this type. 1 by x minus 2 plus 2 by x minus 1 is equal to 6 by x. Now looking at this, it is not looking like a quadratic equation at all. But now if we take the denominator to be this, and we make it as x into x minus 1 plus 2x into x minus 2 is equal to 6 into x minus 1 into x minus 2. And then this denominator is for the whole of this equation. So this can be removed, and then we can say that this becomes a quadratic equation. So this is how we can convert some other type of equations which do not look like a quadratic equation in the original form. They can be converted into quadratic equations and then solved. So friends, now let's look at the properties of a quadratic equation. A quadratic equation has two and only two roots which may be either equal or distinct. A quadratic equation cannot have more than two different roots. So the two roots that a quadratic equation may have may be same or different. If this is the quadratic equation that we are talking about, it may have two distinct roots or two equal roots. Now we can take an example of each one of those. Supposing we have a quadratic equation of the nature x square plus 4x plus 4 equal to 0. Then this equation has equal roots and each of them being minus 2. And if we have another equation of the type x square plus 3x plus 2 equal to 0, then this will have two roots which are distinct. So these are the only two possibilities. A quadratic equation cannot have more than two distinct roots. Now if alpha is the root of a quadratic equation ax square plus bx plus c equal to 0, and this being the general form of a quadratic equation, then x minus alpha is always a factor of this quadratic polynomial on the left hand side of the equation. So in these two examples, if we see x square plus 4x plus 4 equal to 0 has this root minus 2, then this would mean x minus minus 2, which is x plus 2, is a factor of the polynomial x square plus 4x plus 4. Similarly, in this case, x plus 1 and x plus 2 will be the factor of this polynomial x square plus 3x plus 2. Now let's talk about the use of the quadratic equations. So quadratic equations are used in solving problems related to the numbers, ages, mensuration, etc. So we just took an example where we know that the relation between length and breadth is length being 2 more than the width of the garden, and we know its area, so we could calculate the sides of that rectangular garden. So similar kind of problems where numbers, age, etc. are to be found, we can form quadratic equation and then we can solve them. Quadratic equation also used in geometry like Pythagoras theorem, where we have to find one side of a right angle triangle. We use quadratic equations to solve those kind of problems, because supposing we have a square is equal to b square plus c square. So we can get this a quadratic equation from this, and then we can solve it to find the sides. It is also very commonly used in time and distance and time and work type of problems. So for all these problems, we first form a quadratic equation of the word problem and then solve it. And of course, there are many other uses of the quadratic equations. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.